Here we have a SAT math problem. Okay, let's go the question. The figure above shows triangle ABC. The length of AC is 10 and the altitude of the triangle is 20. If M and N are the midpoints of AB and BC respectively, what is the area of the shaded region? Okay, in the given figure, we have to find the area of this shaded region. Okay, my idea to solve this problem is first we have to get the area of the bigger triangle ABC. Once we get the area of this bigger triangle, then we have to get the area of the smaller triangle MBN. When I subtract the area of the smaller triangle MBN from the bigger triangle ABC, I'll be getting the area of the shaded region we have over here. Okay, how do we have to get the area of the bigger triangle ABC? For the bigger triangle ABC, we have the altitude, that is height 20 and the base 10. Okay, we know the formula to get area of a triangle, that is 1/2 times base times height. Okay, using that formula, we can get the area of the bigger triangle. Okay, let me write the stuff. Area of triangle, that is the bigger triangle, ABC equals to 1/2 times base times height. Here 1/2 times the base of the triangle is 10, the height of the triangle is 20. Okay, here 2 goes into 2 1 times and 2 goes into 10 5 times. And here 1 times 5 is 5, 5 times 20 is 100. Okay, now I got the area of the bigger triangle ABC, that is 100 square units. Now I have to get the area of the smaller triangle MBN. Okay, here the question says that this M and N are the midpoints of the sides of the triangle AB and BC. Okay, since this M and N are the midpoints of the two sides of the triangle AB and BC, this MN is the mid segment of the triangle. Since this MN is the mid segment of the triangle, it is parallel to the side AC of the triangle. So clearly MN and AC are parallel. Since MN and AC are parallel, we can consider this AB and this BC as a transversals. Then the angle measured we have over here and the angle measured we have over here are corresponding angles and they must be equal in measure. And also the same thing, that is the angle measured we have over here and the angle measured we have over here are corresponding angles and they must be equal. Okay, and also let me consider the angle at the vertex V over here. Actually, this angle is a common angle for both the smaller triangle MBN and the bigger triangle ABC. Okay, now the three angle measures of the smaller triangle MBN are equal to the three angle measures of the bigger triangle ABC. By angle similarity postulate, the two triangles, the smaller triangle MBN and the bigger triangle ABC are similar. And also, since MN is the mid segment of this triangle, the length of this MN will be half of the side of the triangle AC. Already we know that the length of the side AC is 10. Then the length of this mid segment MN is half of this 10, that is 5. Okay, now we can find the ratio of the sides of the smaller triangle and bigger triangle. Let me write the stuff over here. Ratio of the sides of the smaller triangle and bigger triangle. Okay, for that we can use the sides MN, corresponding sides MN of the smaller triangle and AC of the bigger triangle. So the length of the side MN is 5, the length of the side AC is 10. Okay, here both the terms are the greatest common divisor 5. When I divide both the terms of this ratio by 5, I am getting 1 to 2. So the two triangles are similar and their sides are in the ratio 1 to 2. Okay, then what is the ratio of the areas of the smaller triangle and bigger triangle? Let me write the stuff over here. Ratio of the areas. Let me write ratio of the areas equals to. Okay, now to get the ratio of the areas of the smaller triangle and bigger triangle, what I have to do is I have to square this number and this number. Then I'm getting 1 square to 2 square, that is equal to 1 to 4. So if the sides of the two similar triangles are in the ratio 1 to 2, then the areas are in the ratio 1 to 4. Okay, from this ratio, if I want to get the area of the smaller triangle and area of the bigger triangle, I have to multiply the terms of the ratio by the same non-zero number, say x. That is area of triangle, the smaller triangle, that is MBN equals to, we have to multiply the first term by some non-zero number, say x, that is 1 times x is x. And now let's find the area of the bigger triangle ABC. To get area of the bigger triangle ABC, I have to multiply the second term of the ratio by the same non-zero number x, that is 4 times x is 4x. But already we have the area of the triangle, bigger triangle ABC, that is 100. Here we got the area of the bigger triangle ABC as 4x. So this 100 and this 4x represent the same stuff, that is area of triangle ABC. So we can equate them, that is 4x equals to 100. Okay, now let me divide both sides by 4 to solve for x. This 4 will cancel out. Then I'm getting x equals to 100 divided by 4 is 25. Sorry. Okay, now I got the value of x. Actually, the x represents the area of the smaller triangle MBN. Now we got the area of the smaller triangle MBN. Okay, as we have planned earlier, to get the area of the shaded region, we have to subtract the area of the smaller triangle MBN from the area of the bigger triangle. Okay, let me write the stuff over here. So required area, that is required area means the area of the shaded region is equal to, first we have to write the area of the bigger triangle ABC 100, negative we have to write the area of the smaller triangle MBN, that is 25. So when I do so, I am getting 75. So 75 square units is the area of the shaded region.